A circle of figures huddled close around the fire. Above them, the night sky stretched endlessly, a dome studded with stars. One of the elders pointed upward. The others followed his gaze, watching as he traced shapes in the sky. For these early humans, the heavens were not just an empty expanse, they were alive, filled with mysteries. And in their primal way, they asked a question that would echo through millennia. Who created all of this? We believe in the Big Bang theory that everything came out of a chemical explosion. But then, who caused that explosion? And how did a unique being like a human with 30 trillion cells, with an intelligent brain and a heart, come into existence? Who created the sun, the moon, the animals, and the flowers? There is no doubt that there is a creator whom we call God. But who is this God? Where is God in the universe? As always, one question leads to another. If there is a creator, whether it's a personal deity or a cosmic principle, where did it come from? Who created it? Did it spring from some greater force, or has it existed eternally outside the rules of cause and effect? For centuries, humanity has turned to both religion and science for answers. We've looked for God in sacred texts and in the uncharted realms of deep space. We've built temples and launched telescopes, all in pursuit of a truth that remains just out of reach. But what if the answers are out there, hidden in the very fabric of the universe? What if the strange phenomena we observe, black holes, dark matter, the Big Bang, offer clues about the origins of existence itself? Could the search for God lead us to the edge of the cosmos and beyond? And what if we are all in his imagination? Quiet ambition defined Georges Lemaitre's early years in college. Born in 1894 in Belgium, Lemaitre grew up in a world that was both deeply religious and increasingly enamored with science. The son of a Catholic family, he entered the University of Louvain with an intense curiosity about the universe and a strong faith in God. But Lemaitre wasn't content with simply following the doctrines of the Church. He believed that truth, whether revealed through scripture or uncovered through scientific discovery, ultimately led back to the same source. For Lemaitre, understanding the universe was a form of worship, a way to glimpse the mind of God. However, Lemaitre's religiosity wasn't rigid or dogmatic. He was deeply intellectual, someone who questioned and pondered rather than blindly accepted. As a young man, he pursued studies in engineering and then enlisted in the Belgian army during World War I. The horrors of war didn't weaken his faith. Instead, they deepened his resolve to understand the greater meaning of existence. After the war, he returned to college, this time to study mathematics and physics, fields that seemed to offer a path to the secrets of the cosmos. He also entered a seminary, committing himself to a dual vocation as both a scientist and a priest. In those years, Lemaitre was caught between two worlds, the ancient spiritual realm of the Church and the emerging, often hostile world of modern science. The early 20th century was a time when the scientific community was fiercely protective of its independence from religious influence. The Enlightenment had, after all, been a reaction against centuries of Catholic dominance, a period during which the Church had often suppressed scientific thought. Figures like Galileo and Copernicus had clashed with religious authorities, and by Lemaitre's time, many scientists viewed religion as an obstacle to progress. To suggest that science could coexist with theology, or worse, that it could support theological ideas, was almost heretical in itself. But Lemaitre had a different vision. He believed that science and religion were not enemies, but complementary ways of understanding reality. In his mind, science could reveal the mechanisms of the universe, while faith could offer insight into its purpose. He wasn't interested in proving God's existence through scientific means. Rather, he saw science as a way to deepen humanity's appreciation of the divine. His approach was subtle and thoughtful, rooted in the belief that truth in one domain could illuminate truth in another. This conviction led Lemaitre to one of the most profound scientific discoveries of the 20th century. In the early 1920s, the prevailing scientific consensus was that the universe was static and eternal. Many leading scientists, including Albert Einstein, believed the cosmos had no beginning or end. It simply existed in an unchanging state. This idea, known as the steady-state theory, was comforting in its way. It suggested a universe without origin, and therefore without the need for a creator, a view that aligned well with the secular, post-Enlightenment mindset of many scientists. Lemaitre, however, was not convinced. As he delved deeper into the field of cosmology, he began to consider the implications of Einstein's general theory of relativity, which described how massive objects warped the fabric of space and time. Lemaitre saw something in the equations that others had overlooked, the possibility that the universe wasn't static but dynamic, that it could be expanding. If this were true, it meant that the universe must have been smaller in the past, possibly even condensed into a single point. Lemaitre's mind raced with the implications. If the universe had a beginning, a moment when everything, space, time, energy, and matter, emerged from a single, infinitely dense point, then this could be described as the day without yesterday. It wasn't just a scientific hypothesis, it was a profound philosophical and theological idea. To Lemaitre, this primal moment of creation, later known as the Big Bang, echoed the opening lines of Genesis. In the beginning, God created the heavens and the earth. He presented his ideas cautiously at first, aware of the skepticism he would face. In 1927, Lemaitre published a paper proposing that the universe was expanding and that its current state could be traced back to a single, explosive origin. His work was groundbreaking, but it was also met with resistance. Many in the scientific community dismissed his theory as an attempt to smuggle religious ideas into physics. Even Einstein, whose equations had inspired Lemaitre's work, initially rejected the notion. "Your calculations are correct, but your physics is abominable," Einstein reportedly told him. The resistance wasn't surprising. The idea of a finite beginning to the universe was unsettling to many scientists. It seemed to open the door to theological interpretations, challenging the secular, eternal universe that had become a cornerstone of scientific thought. But Lemaitre persisted. He refined his theory, gathering more evidence and developing mathematical models to support his ideas. Over time, his work began to gain traction, particularly as new observations lent support to the concept of an expanding universe. In 1929, American astronomer Edwin Hubble made a crucial discovery. Galaxies appeared to be moving away from each other, suggesting that the universe was indeed expanding. This observation provided the empirical backbone for Lemaitre's theoretical framework. Gradually, the scientific community began to take Lemaitre's ideas more seriously. The term Big Bang was coined, ironically, as a dismissive joke by astronomer Fred Hoyle, who remained a steadfast opponent of the theory. Yet the name stuck, and so did the theory, as more and more evidence accumulated in its favor. By the mid-20th century, the Big Bang theory had become the dominant model for explaining the origin of the universe. For Lemaitre, this was more than a scientific triumph. It was a vindication of his belief that science and faith could illuminate each other. He saw the Big Bang not as proof of God's existence, but as a way to appreciate the grandeur of creation. He was careful not to conflate his scientific work with his theological beliefs, maintaining a clear boundary between the two. Yet his discovery resonated deeply with his faith, affirming his view that the universe's origins were a mystery worthy of both scientific and spiritual exploration. 4 decades after George Lemaitre first proposed the idea of a universe expanding from a primeval atom, a young Stephen Hawking defended his doctoral thesis at Cambridge. The topic? The nature of the universe's origins, a question that had haunted thinkers since Lemaitre and even before. But where Lemaitre, a Catholic priest and cosmologist, saw his work as harmonizing science with a divine creator, Hawking's journey would take a different turn. By the time he proposed his no-boundary model 2 decades later, his views on God and the cosmos stood in stark contrast to those of his predecessor. Hawking's personal life was as complex as his theories. In 1963, at the age of 21, he was diagnosed with amyotrophic lateral sclerosis, a devastating disease that doctors believed would leave him with only a few years to live. Against the odds, Hawking not only defied his prognosis, but also revolutionized our understanding of the universe. His early marriage to Jane Wilde, a devout Christian, provided him with emotional support during those challenging years. Jane's faith gave her strength, but as Hawking's career progressed, his atheistic convictions deepened. He often dismissed the notion of a personal God, and by the time he developed the no-boundary proposal in the 1980s, his stance on religion had solidified. This growing ideological divide strained their marriage. While Jane clung to her belief in a higher purpose, Hawking became increasingly focused on the idea that the universe could be fully explained without invoking a creator. Hawking's no-boundary proposal was his most ambitious attempt to address the fundamental question of where the universe came from. To understand it, one must delve into the fabric of space and time. According to Einstein's theory of general relativity, gravity is not just a force, but a warping of space and time by mass and energy. Under extreme conditions, such as those near a black hole or at the moment of the Big Bang, this warping becomes so intense that traditional physics breaks down. Hawking had already made significant contributions to the study of black holes, demonstrating that they aren't entirely black, but emit radiation, now known as Hawking radiation. This work led him to ponder the universe's beginning. Lemaitre's Big Bang theory described a universe expanding from an incredibly dense point, a singularity where space and time began. But Hawking wondered, could the universe avoid this singularity altogether? Working with James Hartle, Hawking proposed the no-boundary model, a theory grounded in the principles of quantum mechanics. In this model, the universe doesn't start from a singular point, but rather from a smooth, finite state. To visualize this, imagine the Earth. When you travel north, you eventually reach the North Pole. But the North Pole isn't an edge or boundary of Earth. It's a point where the concept of north ceases to exist. Similarly, in Hawking's model, time behaves like a spatial dimension at the universe's origin. As you go back in time, you don't hit a boundary or singularity. Instead, time transitions into a kind of curved geometry, smoothly blending with space. Hawking explained this transition using imaginary time, a mathematical concept where time is treated as if it were a spatial dimension. In his words, the universe would have neither beginning nor end. It would simply be. This was a radical departure from the traditional view of a universe with a definite starting point. In A Brief History of Time, he described how in this model, the universe could spontaneously create itself out of nothing according to the laws of quantum mechanics. This idea profoundly shaped Hawking's view of the cosmos and the role of a creator. If the universe could exist without a singular beginning, then the need for an external creator, in his view, diminished. He wrote, "Because there is a law such as gravity, the universe can and will create itself from nothing." For Hawking, the beauty of the no-boundary proposal lay in its self-sufficiency. It painted a picture of a universe governed entirely by physical laws, emerging naturally and inevitably from quantum fluctuations. Not everyone found Hawking's vision of a self-creating universe entirely convincing. Some argued that his reliance on the laws of physics to explain existence still left unanswered questions. Where do those laws come from, and why do they operate in such an orderly, life-permitting way? If the universe is a grand machine, they pointed out, even the most sophisticated machine requires a designer to set its rules. In their view, Hawking's framework didn't eliminate the need for a deeper explanation. It simply shifted the mystery one level higher. In 2010, when Stephen Hawking released the grand design, it stirred a profound debate in both scientific and philosophical circles. Hawking's assertion that, because there is a law such as gravity, the universe can and will create itself from nothing, was a bold statement, one that aimed to close the gap between science and metaphysics. Among those who responded was John Lennox, a mathematician and philosopher of science at the University of Oxford, who believed Hawking's explanation left crucial questions unanswered. John Lennox was born in Northern Ireland in 1943, a region known for its religious and political divisions. His upbringing, however, was unique. His parents were devout Christians, yet they encouraged intellectual curiosity and open dialogue about science, philosophy, and faith. Lennox's father, a businessman, made sure that his son had access to books and encouraged him to think critically about the world. This early exposure to both scientific inquiry and religious thought laid the foundation for Lennox's later work. When Lennox encountered Hawking's argument that the universe could create itself, he saw a philosophical flaw that reached beyond physics and into the realm of logic. Hawking had proposed that the laws of physics, particularly gravity, could enable the universe to spontaneously create itself from nothing. But to Lennox, this assertion presented a contradiction. If the universe is truly nothing before its creation, then the very existence of physical laws like gravity presupposes something rather than nothing. Lennox pointed out a key issue. Laws do not operate in isolation. They are descriptions of processes that require a physical substrate to act upon. The law of gravity, for instance, explains how masses interact in space, but it cannot function in a vacuum devoid of matter and space-time itself. Without a universe in which to act, gravity is meaningless. Lennox argued that invoking the laws of physics as the cause of the universe is akin to claiming that the principles of aerodynamics could cause an airplane to exist without a manufacturer. Laws describe what happens under certain conditions. They do not generate those conditions. Hawking's reliance on quantum mechanics as a mechanism for the universe's creation also came under Lennox's scrutiny. To Lennox, while the no-boundary proposal is an ingenious mathematical solution, it still depends on the existence of a pre-existing quantum field governed by certain laws. The model avoids the classical singularity, but does not eliminate the need for an initial set of conditions. Lennox argued that explaining the universe's origin through a quantum wave function merely shifts the question one step back. Why does this wave function exist, and what determines its specific form? Hawking's model, Lennox contended, stops short of addressing the deeper issue of why there is something rather than nothing. The problem, as Lennox saw it, was one of infinite regression. Every attempt to explain the universe's existence through purely natural mechanisms seems to require an underlying framework, laws, constants, or fields that itself demands explanation. If the universe arose from a quantum vacuum, one must ask where the laws governing the quantum vacuum came from. If those laws are taken as a given, then they too become part of the mystery. For Lennox, this chain of questions cannot be answered within the confines of the system itself. It points to the necessity of an external cause, one that transcends the natural order. Lennox's critique of Hawking also draws on philosophical arguments about causality. One of the most enduring principles in both science and metaphysics is that every effect must have a cause. Hawking's claim that the universe could create itself, Lennox argued, violates this principle. A self-causing entity would need to exist before it exists, which is a logical impossibility. To illustrate this point, Lennox often referenced the story of Baron Munchausen. Once upon a time, deep in the heart of German folklore, there was a man known for his wild tales and impossible adventures, Baron Munchausen. He was the kind of man who could captivate any audience with his outlandish exploits, spinning stories so bizarre that even the most gullible would raise an eyebrow. But of all his legendary feats, none was more absurd than the tale of the swamp. The Baron found himself trapped in a swamp, sinking deeper with every passing moment. The muck clung to him, pulling him down, and there was no one around to lend a hand. But with a sudden flash of inspiration, he reached up, grabbed a fistful of his own hair, and began to pull. And as the story goes, by sheer determination and strength, he lifted himself, horse and all, out of the swamp and onto solid ground. The crowd would laugh, entertained by the sheer audacity of it. But the humor of the tale lies in its impossibility. You cannot lift yourself by your own hair. There is no leverage, no external force, no solid point from which to push. It's a perfect metaphor for the absurdity of self-causation. For the universe to create itself, it would need to exist before it existed, a logical contradiction. It's as if the universe is attempting to pull itself out of the swamp of non-existence by its own hair. Just like Munchausen's tale, it's an amusing idea, but one that collapses under closer examination. Something cannot cause itself because, in order to cause anything, it must first exist. The problem becomes even more apparent when considering the nature of nothing. In the context of the universe's origin, nothing doesn't mean an empty space or a quiet void. It means the absence of everything. No space, no time, no energy, no laws. Absolute nothingness is not a state that allows for spontaneous events because there's no framework for anything to happen. To suggest that the universe could spring into existence from such a state is to propose a miracle without a miracle worker. This line of reasoning points to the necessity of an external cause, something outside the system of the universe. For the cosmos to come into being, there must be a cause that itself is not caused. A foundational reality that exists independently, not bound by the laws and limits of our universe. This uncaused cause would provide the necessary grounding for the existence of everything else. It's a concept that aligns with a long tradition of philosophical thought. From Aristotle's unmoved mover to more contemporary discussions, the idea of a necessary being has been central to debates about the origin of the universe. This being, unlike everything else, would not require an explanation for its existence. It would simply be serving as the ultimate source of all that is. Such a notion challenges the view that the universe is self-contained and self-explanatory. It suggests that the cosmos is not a closed system, but rather a creation that points beyond itself. The intricate laws of nature, the precise fine-tuning of physical constants, and the very fact that we can observe and understand these phenomena hint at a deeper reality. A reality that is not subject to the constraints of space and time, but rather the source from which space and time emerge. To illustrate this point further, consider the fine balance of conditions that make our universe hospitable to life. The constants of nature, the values that govern the behavior of everything from subatomic particles to the largest galaxies, are tuned with such precision that even the smallest deviation would render the cosmos utterly inhospitable. Take, for instance, the strength of the gravitational constant, which dictates how objects with mass attract each other. If gravity were just a fraction stronger, stars would burn through their fuel too quickly, collapsing into black holes before life could evolve. If it were slightly weaker, stars would never ignite, and the universe would remain a dark, cold expanse. Then there's the electromagnetic force, which controls interactions between charged particles. This force is responsible for the chemistry of life, the formation of molecules, and the behavior of light. If its value were altered even marginally, atoms could not hold together and no complex chemistry would be possible. Similarly, the ratio of the masses of protons to neutrons affects nuclear reactions inside stars. A small shift in this ratio would prevent the formation of essential elements like carbon and oxygen, the building blocks of life. Even the rate of cosmic expansion, governed by the cosmological constant, plays a critical role. If the expansion were too rapid, matter would disperse before galaxies could form. If it were too slow, the universe would collapse back in on itself. The cosmological constant is tuned to an astonishing degree, to within 1 part in 10 to the power of 120, a level of precision that defies comprehension. It's as if the universe sits on a razor's edge, balanced perfectly to allow the emergence of complexity, structure, and ultimately, life. Another striking example is the strength of the strong nuclear force, which binds protons and neutrons in the nucleus of an atom. If this force was slightly weaker, atomic nuclei wouldn't hold together, and the universe would consist solely of hydrogen. If it were slightly stronger, stars would burn through their nuclear fuel too quickly, again precluding the possibility of life. The delicate interplay of these constants raises profound questions. How could a universe so finely tuned to support life arise by chance? The improbability of such a scenario suggests that something more than randomness is at play. This precise calibration of the cosmos is what scientists refer to as the fine-tuning problem, a phenomenon that has intrigued physicists and philosophers alike for decades. Some scientists, like Max Tegmark, suggest that perhaps our universe is just one of many, each with its own set of laws and constants. Yet even this idea seems to push the question further back. Why would such a multiverse exist, and what are the underlying reasons for its formation? Could the very structure of the universe, with its improbable order and intricate balance, be pointing to something or someone beyond the realm of mere chance? The renowned astrophysicist Sir Martin Rees, who served as the Astronomer Royal of the United Kingdom, has said, that the existence of life is not just a product of random events, but of very specific conditions. Rees, along with other cosmologists, has emphasized that the universe's fine-tuning cannot be explained by chance alone. Instead, it points to an intelligence behind the universe's design. Another leading physicist, Paul Davies, has gone even further in suggesting that the very laws of physics that govern the universe might not just be accidental, but could be part of a deeper principle. According to Davies, the universe may not simply follow arbitrary laws of nature. Instead, those laws could be the work of an intelligence beyond the universe itself. His work emphasizes that the universe's remarkable ability to support life, its precise set of laws, and the conditions that allowed life to evolve all point to something more than mere chance. In fact, the fine-tuning argument has become one of the strongest pieces of evidence in favor of the existence of God as the creator of the universe. The more scientists learn about the cosmos, the more they are confronted with the staggering precision of the universe's design. If the constants were altered by even a small fraction, life would be impossible. This points unmistakably to a purposeful creator, a God who not only initiated the universe, but calibrated its laws and constants with an intentional goal in mind. Consider, too, the work of Francis Collins, a physician-geneticist and the former director of the National Institutes of Health. Collins is renowned for his leadership of the Human Genome Project, which mapped the entire human genome. Yet beyond his scientific contributions, Collins is a devout Christian who has openly discussed the compatibility between his faith and the scientific understanding of the universe. For Collins, the fine-tuning of the universe is evidence of a creator's presence and work. He has argued that the structure of DNA, the complexity of life, and the intricate balance of the universe's physical laws are not products of blind chance, but reflect the hand of a purposeful creator. From Sir Roger Penrose to Alan Guth, all have acknowledged the extraordinary precision of the constants that govern the universe. Penrose, for example, has argued that the improbability of the universe existing in such a finely tuned state suggests that it could not have arisen by chance alone. Instead, the cosmos, in all its complexity and order, seems to reflect an underlying intelligence that set everything in motion. Just as a watch requires a watchmaker, the universe, with its intricate laws and constants, requires a creator who designed and set those laws into motion. Yet, even as the evidence for a creator grows stronger, a perplexing question remains. If the universe requires a creator, who created the creator, and where did this intelligence come from? The Bodleian Library at Oxford, steeped in history and scholarly pursuit, often provided a tranquil backdrop to Alistair McGrath's intellectual journey. As a former atheist turned theologian and historian of ideas, McGrath spent countless hours amidst its rows of ancient tomes and modern texts, exploring the interplay between science and faith. This vast repository of knowledge mirrored the journey of his own mind, a space to reconcile the rationality of science with the depth of theological inquiry. His scientific training sharpened his ability to question assumptions, analyze evidence, and seek coherent explanations. Yet, as he delved deeper into theological questions, he found himself wrestling with a profound problem. If God created the universe, who created God? This question, deceptively simple, unraveled into a deeper puzzle known as the paradox of infinite regression. McGrath considered how the paradox of infinite regression intersected with both scientific and theological thought. To understand it fully, he needed to dissect its implications. At its heart, the paradox of infinite regression is about causality, a fundamental principle that governs both philosophy and science. It posits that every effect must have a cause, and that every cause leads to an effect. It's this sequence, this chain of events, that forms the foundation of how we interpret everything, from the movement of atoms to the unfolding of cosmic events. And yet, when we apply this idea to the very origin of the universe itself, we face a dilemma that cannot easily be resolved. Imagine a simple billiard table with a row of balls in front of you. You pick up the cue stick, position it, and with a firm strike, send the cue ball hurtling toward the first ball in line. The moment the cue ball hits the first ball, the force transfers from one ball to the next, and the chain of movements begins. The second ball hits the third, and the third hits the fourth, and so on, sending the entire sequence into motion. Each of these movements can be traced back to a cause: the cue stick hitting the cue ball striking the first ball, and so on. At every point in the sequence, we can identify a cause and effect. Now consider this. As the balls move across the table, the causes that set them in motion seem self-explanatory. The force you applied to the cue ball makes the first ball move. The momentum of the first ball causes the second ball to move, and the chain continues. But what happens if you ask, what caused the cue ball to move? The cue ball didn't just spontaneously roll, it was struck by the cue stick, which was wielded by your arm. But why did your arm move? And what caused your muscles to contract and move your arm in the first place? The chain of causes seems to go backward infinitely, with each cause requiring another cause to explain it. This is where the analogy begins to unfold the problem of infinite regression. If every cause has a preceding cause, then the question becomes, where does it end? Can we trace the movement of the cue ball back infinitely, or does there have to be a starting point? If the balls and the entire game of billiards depend on an endless series of causes, it would be as though no single ball was ever truly set in motion. In an infinite regression, we lose the concept of an ultimate origin, a starting point for the chain of events. The chain could go on forever, and yet the very notion of the first cause, of where the movement began, would be lost. Take this concept out of the realm of a simple billiard game and apply it to the universe itself. If every effect, from the formation of stars to the existence of galaxies, depends on a preceding cause, then the question of where the first cause lies becomes absolutely central. What caused the universe to come into existence? According to the law of causality, there must be an explanation for the beginning of everything. But if every cause depends on a prior cause, how could anything ever have begun? If we keep asking, what caused that? We end up in an infinite loop with no starting point to be found. McGrath recognized that this paradox posed a significant challenge to both atheistic and theistic worldviews. For atheists, the paradox complicates attempts to explain the universe purely through natural processes. The Big Bang, often cited as the beginning of the universe, raises the question: what caused the Big Bang? And what caused the conditions that led to it? Without a stopping point, the chain of causality spirals endlessly. For believers, the paradox asks, if God is the creator of all things, who or what created God? The question seems logical, yet it also reveals a limitation in human reasoning. Our minds, shaped by experiences within time and space, struggle to conceive of something or someone that exists outside of these dimensions. In his search for answers, McGrath turned to the concept of a necessary being. This idea, rooted in classical philosophy and theology, suggests that not everything requires a cause. Most things in the universe are contingent, meaning their existence depends on something else. A tree depends on sunlight, water, and soil. A planet depends on gravitational forces and the laws of physics. But if everything were contingent, there would be no foundation for existence. A necessary being, by contrast, exists independently and necessarily. It is the uncaused cause. For many theologians, God is understood as this necessary being. Unlike contingent entities, God's existence does not rely on external causes. Instead, God is self-existent, eternal, and unchanging. This concept resolves the paradox of infinite regression by providing a stopping point, a foundation that does not require further explanation. McGrath found this idea compelling, not because it eliminated the mystery, but because it aligned with the nature of ultimate questions. Just as mathematics accepts axioms that cannot be proven but are necessary for the system to function, theology posits God as the ultimate axiom, a being whose existence underpins everything else. To illustrate the resolution of infinite regression further, considered laws in science. For instance, in physics, the laws of thermodynamics describe energy conservation and entropy. These laws are foundational. They cannot be derived from deeper principles, but are accepted as the bedrock of physical reality. Similarly, in mathematics, numbers like 0 and infinity defy complete explanation, yet are essential for understanding numerical systems. These examples suggest that certain foundational truths may exist beyond the reach of causality or derivation. McGrath also reflected on time itself. Infinite regression assumes an endless chain of events, stretching backward in time. However, modern cosmology suggests that time had a beginning, a point where the fabric of space-time itself emerged. If time began with the Big Bang, then causality, as we understand it, may not apply before the universe existed. This idea aligns with the theological concept of God existing outside of time, as the creator of both time and space. As McGrath pieced these thoughts together, he saw the paradox of infinite regression not as a flaw in logic, but as a window into the nature of ultimate reality. The question, who created God, may feel natural, but it assumes that God operates within the same causal framework as the universe. If God is the creator of that framework, then the question becomes meaningless. It's like asking what lies north of the North Pole. The question presupposes something that doesn't exist. For in Him, all things were created. Things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things have been created through Him and for Him. He is before all things, and in Him all things hold together. While McGrath's attempt for solving the paradox of infinite regression problem offers a fascinating framework for understanding causality and existence, it also invites considerable criticism. One common critique stems from the argument that invoking an uncaused cause, such as God, sidesteps the problem rather than solving it. Critics argue that claiming God is a necessary being exempt from causality appears arbitrary. Why stop the chain of causation with God? Why not suggest the universe itself is the necessary entity, eliminating the need for a divine creator? This perspective is often associated with naturalism, where the universe and its laws are seen as self-sufficient. David Hume, the Scottish Enlightenment philosopher, famously questioned the leap from observing causality within the universe to assuming that causality applies to the universe as a whole. Hume pointed out that human understanding of cause and effect is derived from experience. Since we have no experience of universe creation, any claim about its cause, including the existence of God, is speculative. Hume's skepticism underscores a broader critique. The paradox of infinite regression relies on assumptions about causality that may not apply at cosmic or metaphysical levels. From a scientific perspective, the paradox is often addressed through models that do not require a first cause. For instance, quantum mechanics introduces the idea of events occurring without specific causes, as seen in the behavior of subatomic particles. If causality breaks down at the quantum level, critics argue, it might not apply to the origins of the universe either. Some cosmological theories, like the multiverse hypothesis, propose that our universe is one of many, arising from processes that do not necessitate a singular cause. Furthermore, some physicists and philosophers propose cyclical or eternal models of the universe. In these models, the universe operates in infinite cycles of expansion and contraction, removing the need for a beginning or a first cause. These ideas challenge the theological interpretation of the paradox by suggesting that the universe itself may be eternal and self-sustaining. Another point of contention arises from the assumption that causality is a universal principle. Critics note that causality, as humans understand it, is deeply rooted in the framework of time and space. If the origins of the universe involve a state where time and space do not exist, as some interpretations of the Big Bang suggest, then causality might not apply. This undermines the foundation of the paradox, which assumes a causal chain that requires an explanation. Philosophical naturalism often critiques the theological resolution to infinite regression by arguing that invoking God is a form of God of the gaps reasoning. This critique suggests that attributing the origins of the universe to God fills a gap in human understanding without providing a testable explanation. As scientific knowledge advances, many gaps once attributed to divine intervention, such as the movements of planets or the causes of diseases, have been explained through natural processes. Critics argue that the same may eventually happen with questions about the universe's origins. Despite these criticisms, proponents of the paradox's theological resolution maintain that it provides a coherent framework for understanding existence. They argue that while the critiques raise valid points, they often fail to provide alternative explanations that are equally compelling. For instance, while naturalistic models like the multiverse are intriguing, they remain speculative and lack empirical evidence. Similarly, the rejection of causality at cosmic scales leaves fundamental questions unanswered. Yet all these arguments presuppose one crucial idea: that God, if such an entity exists, is a personal and intelligent being, a creator much like ourselves, only unlimited. This view shapes the entire debate, framing God as a cause, a designer, or a necessary entity. But what if this assumption is misguided? What if God, or the ultimate reality, is something entirely different, not personal or conscious, but a fundamental essence or principle? This line of thought hints at a radically different conception of the divine, one explored by philosophers who view God not as a being, but as the underlying substance of reality itself. Cast out of Amsterdam's tightly knit Sephardic Jewish community in 1656 through a harsh harem, Baruch Spinoza lived in solitude, away from his family, friends, and religious traditions. The herem was pronounced with a ferocity that was rare even by the standards of the time, forbidding anyone in the Jewish community from communicating with him, and was not subject to reversal. Stripped of his communal identity and support, Spinoza adopted a modest lifestyle, supporting himself as a lens grinder while pursuing his philosophical inquiries. The quiet solitude provided him the space to develop his ideas about God, nature, and humanity, which would later be articulated in his most famous works, including the Tractatus Theologico-Politicus and Ethics. However, his departure from the Jewish community wasn't simply due to personal conflict, it was rooted in his revolutionary ideas. By the time of his excommunication, Spinoza had begun to express views that questioned the very foundation of religious belief. He rejected the traditional understanding of God as a personal, anthropomorphic being who intervenes in the world. His radical interpretation of Scripture, seeing it as a human-made document rather than a divine one, was a direct affront to the orthodox teachings of his community. Spinoza's critique of the Bible as a historical and moral work, rather than a divinely dictated text, was deeply unsettling. He argued that the Bible should be studied in its historical and linguistic context, treating it as a human artifact shaped by the cultural and political conditions of its time. By doing so, he dismantled the idea that it held a single, timeless divine truth. These ideas, elaborated in his Tractatus Theologico-Politicus, argued that religious authorities used the Bible to maintain power over people, keeping them in a state of ignorance and superstition. At the heart of Spinoza's philosophy was a radical redefinition of God. Rather than seeing God as a transcendent, personal deity who created the universe and intervenes in human affairs, Spinoza identified God with the totality of existence itself. In the vast expanse of the cosmos, where galaxies swirl and stars are born and die, there is a singular truth that governs everything. This truth is not a mere philosophical concept or a matter of belief, but the fundamental reality of existence. It is the essence that underlies all of creation, the energy, the laws, the intelligence that weaves the very fabric of the universe. It is not a separate, distant force, but the essence of the universe itself. The universe as we know it is not simply a random collection of matter and energy, but a deeply interconnected, living, breathing system, unified by one divine principle. For Spinoza, God is not an external, anthropomorphic being watching over creation from a distance. Instead, God is the very essence of existence, the eternal substance from which all things spring and to which all things will eventually return. There is no distinction between the Creator and the creation because everything within the universe is a direct manifestation of the divine. The stars, the planets, and the galaxies, even the very laws that govern the behavior of matter, gravity, electromagnetism, the strong and weak nuclear forces, are all part of the divine essence. There is no place where this divine essence ends and the universe begins. Everything is one, seamlessly interconnected by a singular, rational principle. The laws of nature are not mere human-made constructs. They are the eternal expressions of this divine intelligence. Gravity does not exist as a force imposed upon the universe by some distant will. It is a manifestation of the divine, a natural order that holds the cosmos together. Similarly, the laws of thermodynamics, the principles of quantum mechanics, and the behavior of light are not arbitrary, but part of the fabric of God itself. The entire universe operates according to these laws because they are not separate from the divine, but are the very principles by which the divine expresses itself in the physical world. Spinoza's view also offers a profound shift in the way we understand time, space, and existence. Time is not a linear progression in which events unfold according to a plan made by an external deity. Instead, time is part of the fabric of the universe itself, a dimension in which everything that exists is interconnected. All events, from the birth of a star to the rise and fall of civilizations, are not random occurrences but are manifestations of the divine plan that is unfolding in time. There is no point where God intervenes to change the course of events. Rather, everything is a continuous unfolding of the divine nature. In this sense, the universe is not something that was created and then left to its own devices. It is an ongoing expression of God, with every moment being a manifestation of the divine intelligence that sustains it. Everything in the universe is interconnected, and everything is governed by the same universal laws. The birth of a star in a distant galaxy is not separate from the flow of a river on Earth. Both are expressions of the same cosmic order. The same laws that govern the orbits of planets also govern the behavior of electrons in an atom. From the largest galaxy to the smallest particle, everything is connected through the same fundamental principles. This interconnectedness is not limited to physical matter. It extends to all aspects of existence, including thought, consciousness, and morality. Human beings are not separate from the cosmos. We are a part of the same divine essence that governs everything else in the universe. Our thoughts, our actions, our consciousness are not separate from the divine, but a part of the unfolding of the cosmic plan. In this sense, our lives are not random events, but part of the larger divine order. Our actions are shaped by the same universal laws that govern the stars, and by understanding these laws, we can come to a deeper understanding of our place within the cosmos. Spinoza's cosmic understanding of God also offers a new sense of meaning and purpose. If everything that exists is a manifestation of the divine essence, then every moment of existence is filled with meaning. There is no need to look beyond the universe for purpose or meaning. The very act of being alive is a reflection of the divine. Our lives are not random or meaningless, but a part of a larger cosmic order. Every action is a manifestation of the divine plan unfolding in time. In this sense, the search for knowledge becomes a spiritual practice. To study the universe, to explore the natural laws that govern it, is to engage with the divine intelligence that sustains it. The pursuit of scientific knowledge, the study of the stars, the understanding of the forces of nature, is not separate from the search for God, but is part of it. As we deepen our understanding of the universe, we deepen our understanding of the divine. Science, philosophy, and spirituality are not separate pursuits, but are all ways of engaging with the same ultimate truth. The interconnectedness of the universe also leads to a sense of humility. If everything in the universe is part of the same divine essence, then humans are not the center of the cosmos. We are not the most important beings in the universe, but are an integral part of a much larger, interconnected system. Our thoughts, our existence, are shaped by the same universal laws that govern everything else in the cosmos. In this sense, we are not separate from nature, but are a part of it, and our understanding of the universe should be rooted in a sense of humility and reverence for the divine intelligence that governs it. Ultimately, the universe is a reflection of the divine essence that sustains all things. There is no separation between creator and creation, because everything is part of the same divine system. The laws of nature, the structure of the cosmos, the behavior of particles, All of these are expressions of the same divine intelligence that underlies everything. The universe is not a random collection of matter and energy, but a unified system, governed by rational laws that are the expression of the divine. And as we come to understand the laws of the universe, we come to understand the very nature of God itself. Spinoza's ideas were revolutionary not only for their content, but also for their implications. By removing the need for a personal, interventionist God, he laid the groundwork for a worldview in which science and philosophy could explore the natural world without deference to religious dogma. Despite, or perhaps because of, their radical nature, Spinoza's ideas sparked fierce opposition during his lifetime. His works were banned by both religious and political authorities, and his name became synonymous with atheism and heresy, even though he never rejected the existence of God. His life in exile remained one of quiet determination. He continued to refine his ideas and correspond with other intellectuals of the time, including prominent figures in science and philosophy. Spinoza's vision of God as an infinite, non-personal substance profoundly influenced Albert Einstein, who saw in this philosophy a framework that aligned with his own understanding of the cosmos. While Einstein is often misquoted or misunderstood as a believer in a traditional personal God, his statements make clear that his concept of divinity was far from conventional. In fact, Einstein repeatedly denied belief in a deity that intervenes in human affairs or possesses human-like qualities. Einstein expressed his admiration for Spinoza's philosophy in a letter from 1929, where he wrote, "I believe in Spinoza's God, who reveals himself in the orderly harmony of what exists, not in a God who concerns himself with the fates and actions of human beings." For Einstein, the God he revered was the embodiment of natural laws, the elegant, unified structure of the universe that science seeks to uncover. Throughout his life, Einstein emphasized his rejection of the anthropomorphic God, prevalent in many religious traditions. He remarked in a 1954 letter to philosopher Eric Gutkind, "The word God is for me nothing more than the expression and product of human weaknesses, the Bible, a collection of honorable but still primitive legends." His spirituality was rooted in awe for the universe's order and rationality, which he saw as far more profound than the simplistic notions of a deity created in humanity's image. This perspective also resonated with Carl Sagan, the renowned astrophysicist and science communicator whose views on the cosmos were deeply influenced by Spinoza's and Einstein's philosophies. Sagan shared the belief that the universe is an interconnected whole, governed by natural laws that are awe-inspiring in their complexity and beauty. In his groundbreaking series, Sagan articulated this view with poetic elegance, stating, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." For Sagan, the idea of God was not a being to be worshipped, but a way to describe the profound connection between humans and the cosmos. The phrase, "we are made of star stuff," reflects the scientific reality that the elements essential for life, carbon, oxygen, nitrogen, and others, were forged in the nuclear furnaces of stars. This cosmic heritage ties humanity to the larger story of the universe, echoing Spinoza's vision of all existence as part of a unified, eternal substance. Sagan's universe knowing itself concept expands on Spinoza's ideas, suggesting that through human consciousness, the cosmos gains a reflective understanding of its own nature. This perspective imbues scientific exploration with a spiritual dimension, portraying humanity's quest for knowledge as an expression of the universe's inherent drive toward self-awareness. Perhaps all these debates about God, whether a Lennox's necessary being, Spinoza's infinite substance, or Sagan's poetic universe, reveal less about the cosmos and more about us. Our interpretations of God might be psychological constructs, reflections of our inner need for meaning, belonging, and understanding in a universe that offers no clear answers. Could it be that in our quest to find God out there, we are really searching for a deeper truth within ourselves? A projection of the human psyche onto the vast canvas of existence? And if so, what might that say about the nature of God or the nature of us? Shadows danced across the ceiling, flickering with the kind of quiet unease that only a restless mind can project. Carl Jung sat at his desk, the faint glow of a lamp casting a circle of clarity amidst the encroaching darkness of the room. He wasn't just a man of science, he was a seeker, the kind who wandered the labyrinth of the human mind, not with a map, but with a relentless question. Why do we, as humans, keep reaching beyond ourselves? Jung believed that the gods we create and the stories we hold sacred weren't just arbitrary inventions. They were reflections of something deeper, something primal. He called them archetypes, universal symbols or patterns rooted in the collective unconscious. A kind of psychic inheritance passed down through generations. To him, these archetypes weren't just ideas floating in the ether. They were alive in every human being, shaping how we see the world and perhaps how we search for meaning. Imagine this. You're standing on the edge of a vast, endless ocean. The waves stretch far beyond what the eye can see. But somewhere deep beneath the surface lies the collective unconscious. It's murky, mysterious, and ancient. For Jung, this ocean wasn't random. It had currents, movements, and shapes. The archetypes were like whales moving through the depths, unseen but undeniable. They were symbols that carried the weight of human experience. Mother, hero, shadow, and yes, even the divine. Jung wasn't just a theorist sitting in an armchair crafting metaphors. His ideas were born from his life, his patience, and his struggles. There's a story about a woman who came to him once, tormented by a recurring dream. In it, a radiant, godlike figure handed her a golden cup. She'd wake up in a sweat, unsure of what it meant. For Jung, the golden cup wasn't just a dream prop, it was a symbol, an archetype. Maybe it represented transcendence or the quest for something higher. But more than that, it pointed to something deeply human, the desire to connect with a force beyond oneself, to make sense of the chaos within. This is where it gets fascinating. Jung saw these archetypes as universal, but he also saw them as personal. They weren't just grand ideas floating in the cosmos. They were tied to your psyche, to my psyche. When people dreamed of gods or talked about divine beings, Jung didn't see it as proof of an external deity. He saw it as proof of something inside us, a need, a hunger, a search for meaning. You might wonder, does this mean Jung thought God wasn't real? Not exactly. For Jung, the reality of God wasn't the point. The point was what God represented. In his view, the divine was an archetype, a symbol of wholeness, of the integration of all the fragmented pieces of the self. When people pray, meditate, or create stories about gods, they're reaching for that wholeness. They're trying to bring order to the chaos, to find a story that makes sense of their lives. Let me pause here and bring this idea closer to home. Think about the stories we love. Whether it's ancient myths, superhero movies, or epic fantasy tales, they all share a common thread: the hero's journey. The hero is often called by a force greater than themselves, faces trials, confronts a shadowy nemesis, and emerges transformed. It's not just a story structure, it's an archetype. And when we watch these stories, we don't just see the hero on the screen, we see ourselves. We're the ones searching for meaning, fighting our shadows, and hoping for transformation. Jung's idea of archetypes isn't just about gods or heroes, though. It's about how we shape our reality. When a person walks into a church, mosque, or temple, they might bow before a statue or kneel in prayer. To an outsider, it might look like they're worshipping an external god. But Jung would argue that what they're really doing is connecting with an inner archetype, the divine within themselves. The rituals, the symbols, the prayers, they're tools to tap into that deeper part of the psyche. This doesn't mean religion or spirituality is an illusion. In fact, Jung thought the opposite. He believed these practices were essential. Without them, people might feel lost, adrift in the vastness of existence without a compass. The gods we create, in this sense, are both mirrors and maps. They show us who we are and guide us toward who we want to become. But what about the skeptic? The scientist who looks at the universe through the lens of equations and data, who sees no need for gods or archetypes? Even they aren't immune. Jung would argue that the search for meaning is universal. For the scientist, the archetype might not be a god in a temple, but the quest for truth, the pursuit of knowledge. The archetype isn't tied to religion, it's tied to humanity. Whether we find it in a lab, a cathedral, or a starry sky, the longing is the same. Jung's own journey was marked by this tension between science and the sacred. He started as a psychiatrist, rooted in the rational world, but his encounters with patients and his own inner struggles led him down a different path. He explored alchemy, mysticism, and mythology, not to abandon science, but to expand it. For Jung, the human psyche wasn't just neurons firing in the brain. It was a universe unto itself, filled with mystery and meaning. One of his most personal explorations of this idea came through his work, The Red Book, a massive, illustrated manuscript where he recorded his dreams, visions, and reflections. In its pages, he grappled with gods, demons, and archetypes, not as external beings, but as parts of his own psyche. The act of creating the book was, in itself, an act of searching for meaning, of trying to bridge the inner and outer worlds. If we step back and look at Jung's ideas from a broader perspective, they challenge us to think about the gods we create in our own lives. Maybe it's not a literal deity. Maybe it's a career, a relationship, or a cause. Anything we elevate to the status of ultimate meaning becomes, in a sense, our god. And just like the archetypes, these gods can guide us or consume us. The question isn't whether we create gods, but why we do, and what they reveal about us. Reflecting on the nature of God through the lens of science, philosophy, and our own inner worlds reveals how deeply intertwined the question of the divine is with our search for understanding. The ideas we've explored, from the origins of the cosmos to the structures of the human psyche, show that the concept of God is less about definitive answers and more about the questions that shape us. Philosophical ideas about the infinite and the eternal challenge our logic. The notion of a creator beyond creation, existing outside time and space, reshapes how we think about causality. Maybe the ultimate truth isn't bound by the rules we understand. Others take a different route, imagining God not as a being, but as the essence of existence itself, a force or reality so woven into the fabric of life that it cannot be separated from it. This view shifts God from a personified creator to an intrinsic presence, infinite and unnameable. Yet it isn't just the cosmos that compels us to think about God. In the end, pondering God isn't about proving or disproving anything. It's about grappling with the questions that give life its richness. Is God the creator of the universe itself, or a projection of the human spirit? Maybe God is all of these, or maybe God is none. What seems clear is that the idea of God continues to evolve as we do. It reflects our understanding of the world, our hopes for the future, and the eternal mystery of existence. For me, God is less a being to be understood and more a presence to be felt, a symbol of the interconnectedness and wonder that make life extraordinary. The end result is that we pray to a God in the form of a statue, an idol. As long as we do not realize the truth about God, we will continue to go round and round in circles. We cannot find God. God is the supreme immortal power. That power is in you, and that power is in me. We have to realize God, and the only way to God realization is through self-realization. When we realize, I am not the body, I am not the mind, I am the divine soul, we realize that the supreme immortal power is the soul in one and all.